Leaving Cert Higher Level 2014 Paper 2 Question 3. You're told 2 different games of chance, shown here, can be played at a charity fundraiser. In each game, the player spins an arrow on the wheel and wins the amount shown on that sector. Each game is fair and the arrow is just as likely to stop in any one sector as any other sector on the wheel. John played game A 4 times and tells us that he has won €8. In how many different ways could he have done this? So game A, how could he win €8? Well, looking at it, there's only one way to win €8, is a 5 and a 3. And he'd have to get 2 zeros, either one of them twice. So let's have a look here at the little box. So he's playing it 4 times. So if he gets the 5 first on the first spin, he has to get a 3 on one of the other spins. So the first one, or the second one, the third one, or the fourth one. And the zeros can fill in to the other boxes. So if 5 is in position 1, there's a total of 3 combinations that can happen. 5300, 5030, 5003. So then if 5 is in position 2, it's going to be the same, and the same for position 3 and 4. So it looks like 3 by 4 equals 12 ways here. Let's do another box for 5 in position 2. If 5 is in position 2, 3 can go in the first one, the third one, or the fourth one. And my zeros would fill out here, and it is following the same pattern. Then if 5 is in position 3, so you may be asked to list, you weren't this year asked to list all the outcomes, you could easily be asked to list all the outcomes. And a nice way to do it is a little box like this, showing where each one can go. If 5 is in position 3, 3 can go in the first box, the second box, or the fourth box. The rest will be zeros. And then 5 in position 4, it's going to give the same result. 3 different possibilities. 5 is in position 4, so 3 would have to be in box 1, box 2, or box 3. The rest will be zeros. And you can see here that there are 12 combinations of what can happen, 3 in each of the boxes, so 12 ways. Part B of this question, to spin either arrow once the player pays €3. So this is an expected value question. Which game of chance would you expect to be more successful in raising funds for charity? So let's do it up here so we can see each of the probabilities in this one is 1 over 5. And we have a 5, a 3, and 2 zeros. So it's 1 over 5 by 5 plus 1 over 5 by 3 plus 1 over 5 by 6 plus 1 over 5 by 0 twice. You could just write 2 over 5 by 0 if you wanted. So we're going to get 5 over 5 plus 3 over 5 plus 6 over 5, and the other 2 are zeros. So 6, 3, and 5 is 14 over 5, which is 2 and 4/5, 2.8. So this game, they're going to pay out 2.8, 280, and they're taking in 3. So they make 20-cent profit in the long run. So over a long period of time, if this game was played 1,000 times, they'd average 20 cents profit for each game. So in the long run. Let's look at the second game. There's 6 sectors. We have a 1, 2, 3, 4, 5, and a 0. Okay, so it's 1 over 6 the probability. 1 over 6 by 1 plus 1 over 6 times 2 plus 1 over 6 times 3 plus 1 over 6 times 4 plus 1 over 6 times 5 plus 0. So we have 1 over 6. I'll put them all, rather than writing the 6 each time, I'll just put a 6 on the bottom. So it's 1 plus 2 plus 3 plus 4 plus 5. And adding these together, we're going to get 15 over 6. Is that right? 15 over 6, which is 2.5. So this game B, they are going to make 50 cents in the long run. So game B is more profitable for charity, and that's what they were asking in this question. Give a reason why. So in the long run, game B will make 30 cents more than game A. You could write that down as well if you wanted, but this is enough information to show that game B is more successful. Part C of this question, Mary plays game B 6 times. Find the probability that the arrow stops in the €4 sector exactly twice. Now, just double check, they were all different in game B. All the odds for success are 1/6 for 4. So the probability of not being a 4 is 5/6. So this is a Bernoulli trial. The probability of success is equal to 1/6, and the probability of failure is 5/6. Now we don't know whether the €4, whether it's in game 1 or 2, in game 1 and 3, game 1 and 4, and so on. So how we eliminate the need to know is 6 NCR2. It's going to be successful twice in 6 turns, and this accounts for all of the successes that it can be within six games. And 6 NCR2 is 6 by 530 over 2 by 1, which is 15. So there's 15 different ways you can be successful twice. And we multiply by the probability of success. The amount of time that occurs is 2, but the probability of failure and the amount of time that occurs is 4. So it's a pretty straightforward question here. This is going to work out to be 0.2009. 0.2009 would be the next 3 decimals, but we don't need them. So 0.2 is the probability that the arrow stops in the €4 sector exactly twice.